Good morning, students. Welcome to General Chemistry class. We'll be looking at atomic structure. I'm Benjamin Ahinkra, and these are my email addresses displayed, my telephone number as well. Let's begin. So, as part of our course content, we'll be looking at the structure of an atom. So we want to introduce what an atom is, atomic number and mass number, electron configuration, isotopes. Then we review what we've learned so far. What is an element? Elements are the simplest substances. There are about 100 different elements, and each element is made up of very tiny particles called atoms. And each element is made up of just one particular type of atom, which is different to the atoms in any other element. For instance, if I have this my gold ring, this gold ring has gold atoms displayed inside a cross section of it. We also have charcoal. This charcoal chalk has carbon elements or carbon atoms inside this carbon element, which is used to manufacture this charcoal chalk. What are the building blocks of an element? John Dalton had the first ideas about the existence of atoms over 200 years ago. However, it's only relatively recently that special microscopes, like the electron microscope, have been used to elucidate the fine structure or the ultrastructure of an atom. No, the electron microscope looks at particulate, minute substances which the human eye cannot see, with the simple microscope or normal light microscope and all the other microscope cannot see. It provides a good magnification for infinitesimal specimen or objects. This image is highly magnified. As seen over here, we can see that gold atoms are displayed as blobs over here, all over. This is a blob, this is a blob, this is a blob, this is a blob, 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 all in a gold, an element gold. So, if you want to look at the structure of an atom or the size of an atom, it's very, very small, infinitesimal. It's like the sand, the various sand particles that make up Mount Everest, the tallest mountain in the whole wide world. It's quite amazing. We have, if you have a diamond, this is the lattice of a diamond or the structure of a diamond. So diamond has what? Atoms, and most of the atoms of diamond are what? Carbon. So the atoms have nucleus. We'll be looking at that shortly. So diamond is made of carbon, the same element as graphite, which is found in pencils. The structure of the atom is made up of protons, neutrons, and electrons. We shall visit this shortly. Protons, neutrons, and electrons are not evenly distributed in an atom. The protons and neutrons exist in a dense core at the center of the atom. This is called the nucleus. So this is the nucleus. This is the nucleus containing protons and neutrons. So the protons are the red colored balls and the neutrons are the green colored balls. Then there is a shell around it. This is one shell, this is another shell. So the shells are named K, L, M, N, O, P, and so on. The first shell takes 2 electrons. The second, third, fourth, fifth, they all take 8 electrons. So the electrons are spread around the edge of the atom. They orbit the nucleus in layers called shells. Another name for a shell is an orbital. What are the parts of the atom? Yes. So let's label the parts. This is an electron. This is the nucleus, the yellow part, containing the neutrons and the protons. Then we have the green being the neutron, then the red ball being the proton. These are various scientists who discovered the structure of an atom. So if you Google 450 BC, which scientists discovered something about the structure of an atom? 1803, 1897, 1907. So look out for these dates and the various scientists who made a discovery of the structure of the atom. Mass and electrical charge. There are 2 properties of protons, neutrons, and electrons that are especially important. Mass, electrical charge. So looking at the table over here, we have proton, neutron, electron. Proton, neutron, electron. So there are 2 properties of protons, neutrons, electrons. These are mass and electrical charge. Proton has mass of 1. Neutron has mass of 1. Electron is almost 0. That it has a mass of 1/1840. Proton is positively charged. A neutron is 0. A neutron is just a neutral person. A neutral person does not take sides. A neutral person has no charge. When you are neutral, you don't belong to left or belong to right. You don't belong to this person or belong to this person. You are in between. You are neutral. You are like a judge. If you are judging two people, a case of 2 people, you don't belong here or you don't belong unless you take a bribe. Then you can go and belong here or belong there. But if you haven't taken a bribe, or you are not a bribe taker and you are a judge, you are a neutral judge. You are 0. Your charge is 0. You are not attracted to the positive, which is proton, or the negative, which is electron. The atoms of an element contain equal numbers of protons and electrons, and so have no overall charge. So an atom contains electron and a proton, and the protons are the same number as the electrons. So there is no charge. They are neutral. It's like a husband and a wife. Bible says that two shall come together and become one, meaning that the woman will bring her problems from her family, the man will bring his problems, and their attraction, they attract together, then they forgive each other and they live their lives. Properties of particles of the atom. So which of these statements relates to a proton, a neutron, or electrons? Negative charge. So only of these three, the only negatively charged particle is the electron. Atomic number and mass number. The atoms of any particular element always contain the same number of protons. For example, hydrogen atoms always contain 1 proton. Carbon atoms always contain 6 protons. Magnesium atoms always contain 12 protons. So, proton, this is the proton number 6 for carbon 12. Proton number is 6. So electron number will also be 6 because it has, every atom has the same number of protons and the same number of electrons. So the number of protons in an atom is known as the atomic number or proton number. So over here the atomic number or proton number is 6. So help me identify the various atomic or proton numbers in this table. Starting with sodium, which has a mass number of 23 and an atomic number of 11. So the atomic number is 11. Iron has an atomic number of 26. That's the smallest number, 26. Tin, whose symbol is Sn, has an atomic number of 50. Fluorine, atomic number of 9. Each element has a definite and fixed number of protons. If the number of protons changes, then the atom becomes a different element. Changes in the number of particles in the nucleus, protons or neutrons, are very rare. They only take place in nuclear processes such as radioactive decay, nuclear bombs, nuclear reactors. This is what it means, that the protons and the neutrons form the core or the most central or important part of the atom. That is, they are found in the nucleus. The electrons are found in orbitals, and they are those who partake in chemical reactions. In chemical reactions, electrons are either given out or they are accepted. They are either shared or accepted. They are given out or taken in to form chemical bonds. So, there is no obvious changes to the protons or neutron number. In instances where the protons or neutrons are altered is when man wants to construct atomic bombs, nuclear reactors, to kill a fellow man, in suicide bombs and whatever, to create radioactive decay. And this one has gone out to produce cancer and the rest in human beings. That's because of man's exploitation of nature, creating atomic bombs. So protons and neutrons are they cannot be touched. They don't change. But if man consciously changes it, it leads to these 3 problems of this world: nuclear bombs, nuclear reactors, radioactive decay. Electrons have a mass of almost 0, which means that the mass of each atom results almost entirely from the number of protons and neutrons in the nucleus. The mass of an electron is 1/1840, which is very negligible. Why? Because electrons stay on the orbit they are always flying, and a flying substance is not supposed to have weight. It's not supposed to weigh so much so that it can fly. So electrons are flying. So they are in orbitals. If their weight is heavy, they will crash into the nucleus. So they are their weight is almost zero or negligible. The sum of the protons and neutrons in an atom's nucleus is the mass number. So the mass number over here is what? 12 protons. Then, like I said, the number of protons or atomic number is the same as the number of electrons. So if you have 12 protons here, you will definitely have what? 12 electrons. But the sum of the protons and neutrons in an atom constitutes the mass number. So if you have 12, this mass number means that 12 protons exist in magnesium and 12 neutrons also exist. So 12 plus 12 gives us 24. So let's look at the table below. Hydrogen has a proton number of 1. That's only 1 proton. Hydrogen has 0 neutrons. It does not have any neutron. So mass number of hydrogen is 1 plus 0, making 1. Lithium has 3 protons and 4 neutrons. So 3 plus 4 gives us 7 for the mass number. Then aluminium has 13 protons, 14 neutrons. 13 plus 14 gives us 27 mass number. So what is the mass number of these atoms? We have helium. Protons 2 plus neutrons 2 gives us mass number of 4. Cobalt. Proton 27, neutrons 32. 27 plus 32 gives us 59. Germanium. Protons 32, neutrons 41. 32 plus 41 gives us 73. It continues. So revise this. How many protons and neutrons are there in an element's nucleus? So we want to identify the protons and neutrons here. Hydrogen, like I said, has 1 proton, 0 neutrons. So 1 plus 0 gives us a mass number of 1. Helium has 2 protons, 2 neutrons. 2 plus 2 gives us 4. Lithium, 3 protons, 4 neutrons. 3 plus 4 gives us 7. Beryllium, 4 protons, 5 neutrons. 4 plus 5 gives us 9. There can be instances where I can give you the mass number and tell you to give me or calculate for me the neutron number. So if I have a mass number of 24 for magnesium and I give you a proton number and I say find the neutron number, you just subtract 12 from 24 to give me a neutron number of 12. The same way, if I have argon, if I give you mass number of argon to be 40 and I give you neutron number of argon to be so and so, maybe 22, then 22 minus 40 gives me the proton number of 18. Atoms have no overall electrical charge and are neutral. This means atoms must have an equal number of positive protons and negative electrons. The number of electrons is therefore the same as the atomic number. Let's see this in the table. Helium has 2 protons, so helium will obviously have 2 electrons. Copper has 29 protons, so it will have what? 29 electrons. So the number of protons correspond to the number of electrons, but the only difference will be the neutron number. What are the missing numbers? So this is an assignment. Boron has 5 protons, 6 neutrons, so it will definitely have 5 electrons corresponding to a 5 proton. The atomic number is the same, is equal to what? When we say atomic number, it's also another name for proton number. So the atomic number will be 5. That is, proton number is 5, the same as atomic number 5. So mass number is what? The sum of the protons and neutrons in the nucleus of the atom. So it gives us 5 plus 6 gives us what? 11. So potassium has 19 electrons. So definitely it will have 19 protons. Then it has a mass number of 39. So 39, so a mass number is what? The number of protons and neutrons in the nucleus of the atom. So if you know, we've computed electrons 19 to be equal to 19 protons. Then if we subtract this 19 from 39, we get the neutron number. Chromium has protons 24, neutrons 28, electrons 24. So definitely the atomic number is the same as proton number. That's another name for it. So here atomic number is 24. Mass number is what? The sum total, or the sum of the number of protons and neutrons in the nucleus of the atom. So mass number will be here. That's 24 plus 28. Are these statements about atoms true or false? The smallest of the subatomic particles are the electrons. True or false? True. Neutrons and protons are positively charged. True or false? False, because definitely neutron has no charge. Number 3. Atomic number is the number of protons in an atom. True or false? True, because proton number is the same as atomic number. The atomic number is the larger of the two numbers shown in the periodic table. True or false? Definitely false, because the larger of the two numbers is the mass number. Compute the rest. Electron configuration. Where are the electrons found in an atom? They are in orbitals. Electrons are not evenly spread, but exist in layers called shells or orbitals. The shells can also be called energy levels. The arrangement of electrons in these shells is often called the electron configuration. So you should be able to define electron configuration as the arrangement of electrons in shells. Here, the first shell is this. Second shell is this. Third shell is this. So there's a mistake here. Arrow 1 should point here and not here. Well, this is the nucleus. That's the nuclear area marked by yellow color. The first orbital, it always takes 2 electrons. Second orbital always takes 8 electrons. Third one takes 8 electrons. Fourth one takes 8. Fifth one 8. So we have what? KLMN. First orbital is called K shell, then L shell, M shell, N shell, O shell, P shell to Z. Note that this diagram is not done to scale. How many electrons per shell? Each shell has a maximum number of electrons that it can hold. Electrons will fill the shells nearest the nucleus. So, the first shell contains 2 electrons. Second shell takes a maximum of 8 electrons. third shell takes a maximum of 8 electrons, and so on. So for this atom, we have what? The electron arrangement is 288. How many electrons are arranged in the elements? So over here, how many electrons? Hydrogen has 1. Helium has 2, because the electron number is equal to what? The number of protons or the atomic number. Lithium has 3 electrons. Sodium has 11. Phosphorus has 15. Sulfur has 16, and so on. It continues. In summary, the nucleus is made up of protons and neutrons. There is the area, green balls for neutrons, red balls for protons. The nucleus is positively charged because of the protons. Protons, like I said, bear a charge of 1+. The nucleus is dense. Dense means what? Heavy. Because it contains nearly all the mass of the atom in a tiny space. So, the protons have a mass of 1. Neutrons have a mass of 1. Electrons have no mass. So all the mass of the atom is in the nuclear area, the nucleus. Electrons are very small and light and negatively charged. Electrons are able to be lost or gained in chemical reactions. So these are the electrons. They are negatively charged. They are very small. They don't have weight because they are flying around the nucleus. So if you are flying, you still have weight so that the air can blow you around. The electrons are thinly spread. The electrons are found in thinly spread. Electrons are spread around the outside of the nucleus, orbiting in layers called shells. What are the missing numbers? So this example looks like the first one. So do this assignment. Isotopes. Elements are made up of one type of atom, but there can be slightly different forms of the atoms in an element. Although atoms of the same element always have the same number of protons, they may have different numbers of neutrons. Atoms that differ in this way are called isotopes. For example, 2 isotopes of carbon are carbon 14 and carbon 13. Why are they isotopes? Because they have different mass numbers, 12 and 13. And they have the same atomic number. So they both have 6 as atomic numbers, but they differ in their mass number because they have different neutron number. Most naturally occurring carbon exists as carbon 12. Only about 1% is carbon 13, and a much smaller amount is carbon 14. So carbon has 3 different naturally occurring atoms. The first carbon is carbon 12, this one. The second is carbon 13. The third is carbon 14. They all have the same electrons. 6. They all have the same proton number or atomic number. 6 protons, 6 protons, 6 protons. But they differ in their neutron numbers. 6 neutrons, 7 neutrons, 8 neutrons. So, as represented in the diagrams below, we have, for carbon 12, it has the same number of protons, the same number of neutrons, the same number of electrons. 6, 6, 6. When we come here, the electron number is not affected. It's still 6. But the proton increased by 1. So the green balls will increase by 1, making 7. The same way over here, the green balls will increase by additional 1, making what? 8. The isotopes of an element are virtually identical in their chemical reactions. This is because they have the same number of protons and the same number of electrons. So they are the same. In chemical reactions, carbon 12, carbon 13, carbon 14 have the same chemical properties. They go through the same chemical reactions because the only difference between them is the neutron number, which is in the nucleus. And like I told you earlier on, the nucleus, or the component of the nucleus, which is protons and neutrons, they don't change. It is only electrons that partake in chemical reactions. So electrons form bonds, electrons of one atom form bonds with another electrons of another atom in the chemical reaction. The neutrons, the protons are not changed. They are not affected by chemical reactions. So isotopes only differ in their physical properties, that is weight, melting temperature, their flow properties, how they flow when you pour it, when it melts, how it flows, viscosity and the rest, because the neutron is affected physically but not chemically. If it's chemically, then it's the electrons that are supposed to be affected. So in a nutshell, the uncharged neutrons make little difference to chemical properties, but their physical properties are affected, such as melting and density. Natural samples of elements are often a mixture of isotopes. So if you take carbon, carbon may contain 95% carbon 12, 3% carbon 13, 2% carbon 14, making 100%. We'll throw more light on this. So let's take hydrogen. Hydrogen has 3 isotopes. The first isotope, which is naturally occurring and the most abundant, is hydrogen. The second is deuterium. The third is tritium. Hydrogen has 1 proton. It also has 1 electron. It has no or 0 neutrons. Recall or remember that the proton number of hydrogen is 1. The neutron, as the proton number is 1, definitely the electron number will be 1. So neutron plus proton gives us mass number. So if the proton is 0, the mass number will be what? 1. Here, deuterium has proton 1, has 1 neutron, so mass number 2. Tritium has proton number 1, 2 neutrons, mass number 3. So as represented below, hydrogen has no neutron. Deuterium has 1 neutron. Tritium has 2 neutrons. So about 75% of naturally occurring chlorine is chlorine 35 and 25% is chlorine 37. So let's see chlorine. Chlorine has, this is the first isotope, chlorine 35, second isotope, chlorine 37. They both have equal number of protons, 17. Equal number of electrons, 17, 17. But they differ in the number of neutrons, 18 and 20. So you can see that the electrons are the same, the protons, that's the red, are the same, but the neutrons, that's the green balls, are many. There are two additional green balls, making it chlorine 37. Almost all of naturally occurring oxygen is oxygen 16, but about 0.2% is oxygen 18. So oxygen 16 is about 99.8%, whereas oxygen 18 is only 0.2%. So let's look at the component of oxygen 16. It has 8 electrons, 8 neutrons, 8 protons. So protons plus neutrons gives us what? The mass number 16. But oxygen 18 differs from oxygen 16 by its having 10 neutrons instead of 8 neutrons. So having a mass number of what? 8 protons plus 10 neutrons giving us 18. Are these statements about isotopes true or false? Isotopes of an element, number 1, have the same number of protons but different numbers of neutrons. It is true. Isotopes of an element have different atomic numbers but the same mass number. They have different atomic numbers but the same mass number. It's false. Isotopes have the same chemical properties but different physical properties. It is true. Natural samples of elements are always made up of just one isotope. It's false. There are 3 isotopes of carbon. Carbon 13, carbon 12, carbon 14 is true. Most hydrogen occurs as hydrogen 1 with 1 proton and 1 electron and no neutrons. It's true. Summary. So let's go through this. The smallest particle, an atom is the smallest particle that can exist on its own. True. Atomic number, the number of protons in the nucleus of an atom, also known as the proton number. So another name for atomic number is proton number. Electrons are negatively charged particles that orbit the nucleus of an atom. An element is a substance made up of only one type of atom, like what we saw in gold. The isotopes are different atoms of the same element. They have the same number of protons and electrons, but a different number of neutrons. True. The nucleus is the dense, positively charged center of an atom, made up of protons and neutrons. A neutron is a neutral particle with a mass of 1. It is found in the nucleus of an atom. Mass number, the number of protons and neutrons in the nucleus of an atom. A proton is a positively charged particle with a mass of 1. It is found in the nucleus of the atom. Forget about this. So complete this sentence about atomic structure. Assignment. Match the words about atoms to their definitions. Assignment. So, okay, are these statements about isotopes true or false? So this one is also an assignment. So please make sure that you do all the assignments in this presentation. Then when you finish doing these assignments, make sure I get this assignment on Friday. All the solve, true or false, and whatever is in this presentation. It's an assignment. So go and finish everything. Make sure that if you don't want any problem, because this assignment is not supposed to be okay, so what we'll do is that you can You can print the assignments alone on a page, then use pen to write the answers, whether true or false, whether the numbers, computation of the electronic configuration. Just do them all inside. So you can print one slide or two slides on a page and do the assignment. Only print the assignments. When you finish, you can keep a copy for yourself and make a copy for me. Staple it, let your name be at the back, type your name at the back, your course, your class, everything, and forward it to me. I'm grateful for this class. On Friday, we'll have our first midterm on what I've taught you, general chemistry, atomic structure. So just go and read this slide, familiarize yourself, make sure you understand everything in this slide, so that Friday we have a quiz. Our first midterm, we'll have about 4 midterms on chemistry, the same for biophysics when we meet. Thank you very much, lovely ones. May the Almighty God be with you and cause His face to shine upon you and give you peace in Jesus' name. Amen.